When all 24 slots are cut, the mic cases are polished with a blast of tiny glass beads. While the casings are being blasted, a worker mills the steel block into the part of the microphone that holds the ribbon and the magnets inside. It's called a transducer. Its job is to convert sound waves into electric signals that a recording device or amplifier can understand. Here's how it works. The ribbon that gives the microphone its name is mounted in the transducer between two magnets. As sound waves come into the microphone, they hit the ribbon, causing it to vibrate. The vibrations disrupt the electromagnetic field between the two magnets, and that disruption converts the sound waves into electric energy. The magnets used in the transducer are so powerful they're known as supermagnets. They're made from iron and a naturally occurring element called neodymium, the strongest magnetic element on Earth. The pull between two supermagnets is powerful enough to work through a human hand. They're used in the microphone because they can pull more energy out of the ribbon to produce a truer, more detailed sound. The ribbons are made from sheets of pure aluminium that are so thin it would take 50 sheets stacked one on top of the other to equal the thickness of a single human hair. Just the slightest touch can turn the aluminium sheets to dust. But this sensitivity is why the ribbons are able to pick up the slightest nuances in sound. To make a ribbon, an engineer uses a razor blade to cut out a strip of the aluminium that's 10 centimeters long and just a fraction of a centimeter wide. The material is far too fragile to be measured, so instead the ribbons are weighed to be sure the dimensions are right. If the weight is correct, the ribbons are carefully fed between two rotating gears in a crimping machine. This is to gently crimp a corrugated pattern into the aluminium. Corrugating makes the ribbon stronger without adding any weight or thickness. The grooves also affect the way the ribbon vibrates to create a richer tone. The gentle pressure applied by the crimper tightens up the aluminium strip. To ensure it won't stretch out once it's in the microphone, the tiny ribbon has to be stretched ever so carefully by hand to relax it after the trauma of the gears. The riskiest part comes next, mounting the fragile ribbon between the two magnets inside the transducer. The ribbon is placed into the slot and screwed down with two brass clamps. The brass not only holds the ribbon in place, it also conducts electricity through the ribbon to move the sound signals through the microphone. Before the screws are tightened completely, the ribbon has to be tuned to reduce noise made by the molecules in the aluminium that could distort the sound quality of the mic. It's such a dicey process. In fact, about 30% of the carefully corrugated ribbons are torn as they're installed and tuned. The ribbons that make it into the transducers intact are covered with stainless steel screens to protect them from dust and dirt. Now the transducer can be wired for sound. A small transformer is soldered to the brass clamp at the base of the transducer. It amplifies the electric signals so they can be heard as they come out of the microphone. Once the transformer is in place, it's time to assemble the microphone. To start, a worker adds a windscreen to the inside of the protective steel casing. The screens will protect the delicate ribbon when it's inside the microphone from the pressure of wind and loud noises that could cause the ribbon to tear. Next, the combined transistor and transducer, which hold the ribbon and the two magnets, slide into two long slots along the side of the casing. A little cotton is wedged inside the case to prevent the wires on the transformer from rattling around inside the mic. Finally, the top cap and bottom connector are snapped into place. This microphone is now ready to capture any musical or vocal performance without any distortion or loss in the quality of the sound.